In this video, we're going to dive into the simplest way to get more work done. Now, the caveats here are that none of the jobs need to talk to each other. You're just trying to get all the work done in the jobs. You have a list of things that are either I/O bound or CPU bound. And so we're going to go to the first easiest way to do things, and that is in concurrent futures. The base class is Executor, but you have a ThreadPoolExecutor and a ProcessPoolExecutor, but they have both the same API. Now, within that, we're only going to talk about mapping, which is the simplest way to do it. And mapping just takes a big list of iterable inputs and maps it into a pool of either thread workers or process workers, and then does the work, and it returns in order as they get done. So again, if you have a variable time, or maybe the last job doesn't take much time and the first job does, there are other ways to do this, but we're going to start with the simplest, and that's ThreadPoolExecutor and ProcessPoolExecutor with the map function. So right now we're going to import request, which I'm going to use to grab URLs, and import time so that we can time this thing. And then from concurrent futures, which is the module that has all this stuff in, we're going to import ThreadPoolExecutor and ProcessPoolExecutor. Now here I've got a list of the top 50 websites, minus 2 that don't seem to be there or the URL wasn't returning, and I've got them in a list. Here I've created 2 tasks. One is an I/O task where I go out and I request that URL and get the information from it and return it. So it's just a request.get. I do a little bit of processing to tack on a www if it didn't have one, or I leave it alone if it's already got more than 3 parts to it. Then I've got a CPU task. Now this is just a made up task. It's just going to do a bunch of multiplication for I in the range, so I throw in big numbers and it takes a while to multiply out that many times. In this you would have something like image processing, or I'm going to do a bunch of hashing, or there's lots of things you could put here, but I wanted to do something simple. But in your mind, when you're choosing between the two, remember, is it CPU bound? I'm going to use ProcessPoolExecutor. Or is it I/O bound? I'm going to use ThreadPoolExecutor. Here we're going to time this thing. I'm just going to grab at the start. I'm going to say all front pages. I'm going to loop through them, and we're going to grab out the front page, the text. And then at the end, I'm just going to say how much time did that take and how big was the amount of text that came back. I'm going to do the same here. So this is serial time and this is parallel time here. So here I'm going to use the context with ThreadPoolExecutor. You give it the max workers. I'm doing 100. I mean, really, it doesn't do any good to have more than the number of tasks. So I could just do length of the top sites. Would be a better way to do this, but it doesn't hurt anything as pool. Then I do my start time, and now this is the magic line right here. So I've got my pool, and I'm going to do pool.map. Now I give it the function that has the task in it, and then I give it that list of work to submit to the task. And so it's going to take each one of those URLs, and it's going to send it as, it's going to call I/O task with that as a parameter. And then I put it all together to see how much text comes back, and I run it. And then we're going to print out the parallel time. I could run this, but it takes quite a bit of time, almost 50 seconds. Pretty boring to watch that. However, if I do it in parallel, look at this, 2.5 seconds. Massive pickup in speed. And really, the only limit is my bandwidth here at where I'm doing the filming. Otherwise, it could grab as many as you wanted. Same about the same amount of text, maybe a little different each time you pull. That's how you do and split up I/O bound work. It's with that ThreadPoolExecutor map, throwing in a list of items that you want to do the work on. Now we're going to do the same for the CPU stuff. And here we're going to use numbers 500,000 to 500,000, 200, and that will iterate through and multiply. It's just make work. I mean, you could be doing crypto mining. Doesn't really matter. So again, I'm going to run these now. This time it's the same thing. You get your ProcessPoolExecutor, so the ThreadPoolExecutor as pool. Now here, I didn't say max workers. If you don't give it max workers, it'll give you a pool worker for every CPU core that you have. Now if you're on an Intel machine, it can run 2 processes per core, so it'll be 2 times the number of cores. And then we're going to start it, grab the pool, run map on it, throwing in the work. The work is that range, and see how long it takes. Now this one I'm going to run because it finishes in a decent amount of time. Now interestingly enough, this worked on my Ubuntu machine but does not work on my Mac here, where I try to do the same thing with ProcessPoolExecutor as I did with ThreadPoolExecutor. So in order to get around that, I went ahead and created a standalone file for ProcessPoolExecutor. And you can see here it's importing the request, ProcessPoolExecutor. The key thing is if you're running this from a command line prompt, you have to do this check for name equal to main and run it within that or it won't work. It'll throw an error. Here I surround it by this if name is equal to main, and then I do the start time. I do it in serial first, and then I do it in parallel next. And when I go and run this thing, so sure enough, it takes a little bit of time to run. It's about between 7 and 8 seconds, 8.5 seconds this time, and parallel time 2.3. So that's it in a nutshell. The simplest way to do this is with ThreadPoolExecutor and ProcessPoolExecutor map, as long as you don't mind everything coming back as it finishes in the order that you submitted it. So if something finishes earlier, it's going to wait till the first thing finishes, give it to you, then the second thing, then the third thing. But it's drop dead easy to do it this way. If you've got a pile of work and you'd like to move your game up and get into this concurrent processing game, start with ThreadPoolExecutor and ProcessPoolExecutor map. Hope you learned something. Smash that like button so I can help more people. Subscribe if you want to get more of these videos, especially I'm going to be coming out with the whole series on all you need to know about programming concurrently in Python. See you in the next video.